So before we start talking about how to implement continuous updates, the first question would be, why do we bother updating software at all? I mean, there are certain class of software that doesn't require any updating. Who knows what BC is? Anyone? BC?
Binary calculator.
Yes, of course. It's a command line calculator that's been with us since the 60s. The previous name of BC, that's kind of the harder question. It's DC. I don't know why they changed the name. Anyway, as you can see, they are not updating very frequently. I mean, last time it was like almost 20 years ago, and frankly, I have no idea what there is to update. I mean, it's a calculator. Like no, seriously, math didn't change. So I don't know why they needed those updates, but obviously there is nothing much to update. But this is a very rare case. Usually, obviously, the applications are more evolved and they require updates for mainly two reasons. The first would be users. And that's because the users want features and they want new features. When do they want the new features? Now, obviously. They want it now. Right? So this pressure has built up, I would say, in the last, 15 years, specifically, because, well, you know, who's old enough to remember, like, the old Nokia days, early 90s, first mobile phones, right? And then, if you had a phone that didn't have the snake game, and you wanted the snake game, what did you do?
Right.
You buy a new phone. And then you are like very good at Snake, and you kind of, you know, you did all the levels, and then you want new levels, and they are not there. What do? You buy a new phone, right? And then you remember the thing called data cable for Nokia phones? You remember what you could do with it? Install new software? No. You could back up your phone book so you can restore it when you buy a new phone to have more levels of Snake. So that didn't work. And then obviously everything changed with the iPhone and the smartphone. And now you get new levels of Snake whether you want them or not. Right? It's just over there, always updated, and you just keep getting new levels of Snake all the time. And that's because you want it, right? So this pressure is very important, and this is what distinguishes companies that stay in business and companies that go out of business. So this is a real pressure to get software updated. The other is security. I have a friend that said once, as every company becomes a software company, and that's obviously a quote from Forbes, I think, like 2011, security vulnerabilities are the new oil spills. Right? Oil spills were a big deal 10 years ago. Not anymore. We don't hear about oil spills. What we do hear about? Security breaches. So, fighting security breaches are a lot like stopping the car. When you got your license, you probably remember that there is this thinking distance and the braking distance, right? And the thing with those two components is that they are completely different in nature. So thinking distance is about the light that hits your retina and sends some electricity to your brain, and then the neurons are firing, and you realize there is an obstacle, and then you send like more neurons to the leg and issue the command to put the brakes and everything. That's like this part. This part, completely different. It's the chemistry of the compound, of the brakes that creates the friction with the wheel and the friction of the rubber with the asphalt and all this chemistry and physics and all completely different stuff. Now, but the combination of those two create the stopping distance. And so it's pretty clear how do we battle this. It's like mostly chemistry and new compounds. How do we battle this? we remove those slow-thinking humans, replace them with robots that react much faster. Anyway, fighting security vulnerabilities, it's a little bit the same because it has 3 different parts with completely different dynamics, right? So we have to identify, how do we know that we have been breached? There are breaches that are very obvious, like ransomware. They block your screen, they encrypt your files, you know immediately that you have been breached. And then how do you fix it? Or there are others in which they slowly drain your personal data from the known vulnerability and stuff. How do we fix? It's either patching our code if we did something horrible, like we forgot to check our parameters, or something horrible like coding in C with buffer overflows and what's not, right? But mostly it's about upgrading dependencies, right? So applying a patch for your operating system, or changing the version of your dependencies in a log file or a POM file or whatever. And then building, and then the last part is how fast do we deploy a fix. How long it will take us to apply either like a new code build, or, as I mentioned, usually how fast it will take to apply upgrading dependencies. A couple of examples of those numbers. So this is almost 3 years ago, 2.5 years ago. That should be familiar to all of you, right? The disaster that happened in the hospitals with the ransomware. And so what happened? What happened is a very old exploit that was patched for any current operating system of Microsoft, but wasn't patched for a non-support operating system like Windows XP, and the hospitals were running Windows XP. So the OS upgrade that should have been performed many years ago when XP stopped getting security updates wasn't performed, and then it actually took years from the time that they should have patched to the time they actually patched and upgraded Windows. It took years. Another example, this is close to my heart, the Equifax thing, right? So 180 million of, you got it as well. 180 million of credit history records were stolen. What happened? They used this old version of Struts 2. It took them 2 months to discover that they're actually being exposed and the information was drained. And then all it takes is like one line in a POM file or something to upgrade Struts 2, and it took them 2 months to deploy this upgrade. Right? So total exposure time, 4 months, and that's obviously how all the information got stolen, which is pretty bad. But then you say, well, I picked the worst examples, right? One of them, it's like government agency, inefficient. The other is like semi-monopoly. Those credit agencies are also like very, very inefficient. But I mean, we are startups and everything, it won't happen for us. Now, the problem is that if you remember, we started this year, that we're finishing now, with 2 very big security-related news about Meltdown and Spectre, which were CPU hardware breaches that were very, very frightening. The Meltdown was like the big deal because it was like 10 lines of JavaScript code to access memory that shouldn't be accessed and stop password and what's not. But actually, Spectre is the more frightening one. It's the more frightening one because Spectre uses, it's not even an exploit. It's a pattern of how you do exploits. And the way that pattern works is that you analyze well-written software, well-written program, and then you compare with the actual results of speculative optimizations on the CPU. You try to understand how CPU speculates about what will happen next, based on this type of design patterns in the application. And then when you understood how it works, you can make assumption that any application that uses the same design patterns and the same best practices will cause the CPU to perform the same speculative calculations. And then you say, if in my application this part of memory was exposed, in your application it is very much like mine, it will do the same. And you can make this assumption because all our software is very much alike. Because we use design patterns, we use best practices, we copy code from Stack Overflow, and all that. Now, what it actually means is that Spectre attacks are impossible to defeat, are impossible to predict, are impossible to be protected from, because all it takes is well-written code. So what are we going to do? We're going to write shitty code just for people who won't be able to exploit us with Spectre? Of course not. So with Spectre class attacks, we are necessarily in what it's called zero-day exploits. And zero-day exploits means we don't have any warning. We start our day with exploit being in the wild, right? And here is with zero-day exploits, the importance of all those 3 steps being implemented as fast as possible is obviously critical. And this is where what brings us to the second the second necessity for very frequent and very fast upgrades, because we only can we can only be protected if we update as fast as possible. So with those 2 reasons in mind, let's look what's happening in the industry. Who heard about State of DevOps report? Okay, so that is super useful presentation because you just heard about State of DevOps report. This is the most important document in our industry because it actually describes State of DevOps. So let me ask you again, who heard about State of DevOps report? You just heard about it. So everybody. Oh, good. You see, you're a very advanced group. Everybody heard about State of DevOps report. So the way it works is Dr. Nicole Forsgren and her team, they are now in Google Cloud, the research group in Google Cloud, and they survey teams that do DevOps, and there are now over 31,000 groups, and they ask them about different metrics. For example, what is your lead time? And lead time is how long it takes from coding to production. What is your release frequency? What is your fail ratio? How many of your deployments actually fail? And the fourth metric is time to restore. If you have an incident, how fast can they restore service? And but the answers to those 4 questions, they separate the groups into 4 different cohorts: low performance, medium performance, high performance, and elite. And the good news here is that 20% of the industry, every 5th team that they spoke with, are actually elite performance in terms of those 4 metrics. And as I mentioned, one of the metrics which we care about in the context of continuous updates are deployment frequency. How frequent you deploy your code to production. And the right answer here, in terms of the elite group, is on demand. As frequent as you like. It might be multiple deploys per day. And that means that they can meet business needs with unprecedented speed, right? Business says, oh, all right, we want to add 500 new levels of Snake. And boom, they release it the same day. And obviously they can also answer to the security threats, again, patching the software, updating during the same day. So this is where we want to get, and I want to remind you, 20% of the industry is already there. So what I'm going to share with you is not some kind of a distant, utopic future. People actually do it today. Now, people are doing it today because we are 20 years in on those ideas. The ideas from extreme programming, and that's, for a second, 1998, almost 22 years ago, short feedback, that's about that. Scrum, 2000, reducing cycle time to absolute minimum. Again, it's about that. Toyota production system, decide as late as possible and deliver as fast as possible. Kanban, incremental change. All those concepts are about releasing as and updating as frequently as possible. 20 years old. So, with that, hello, my name is Baruch, and I'm the Chief Sticker Officer with JFrog, so I have some stickers over there, because I come with stickers. Also, Head of Developer Advocacy. The most important piece of this slide is my Twitter handle. This is where you follow me, and this is where we chat. And also, it's on the bottom of every slide in case you forget it. This is kind of a disclaimer. A great book by Irene Mayer called Culture Map maps the differences between cultures. This is a very nice diagram that put countries among emotional expressiveness and confrontation lines. So this is the UK, it's right here. Not confrontational, like not to the extreme, but not confrontational and not very expressive. On the other side, you can see that the most emotionally expressive and confrontational people are from Israel and Russia. I'm from both. So I apologize in advance if I didn't offend you during my presentation. I'll do my best to fulfill this promise. Anyway, that's a disclaimer, and yes, I apologize for my style, but the most important slide of presentation is this. You go to jeffrog.com/show notes, you will find probably in an hour from now a page dedicated to this meetup there. I will upload the slides. I will upload the video that I'm recording right now. I'll put all the links there, including culture map and all the security breaches and everything that we spoke until now and will speak after. A place to comment, for ratings, and a small raffle for coming tonight. It's an Amazon Echo Dot. You have a very, very high chance of winning. Because you're not allowed to bid. Right, so go there and check it out. Now, also, this is also on the bottom of every slide, so in case you forget, it's always there. Good, all right. So, let's talk about frequent updates. I want to take one example that might be familiar to most of you of an organization that really wanted to update faster, and that's Java. Mark Reynolds, 2 years ago, announced that they are going to move to a faster release cycle. Instead of releasing nominally every 2 years, but de facto like every 4 years, they are going to release every 6 months no matter what. If they have whatever features are ready, will be released. Whatever is not ready, will go to the next release. That's very cool. Again, 2 years ago, Java 8 was the latest stable version, 2017. Since then, Java 9, Java 10, Java 11, Java 12, and Java 13 are out. We're 5 versions after the announcement. And then we look at the State of Developer Ecosystem report from our friends at JetBrains, and what do we see? 83% of Java 8. I remind you, 5 versions ago, that was the version that was GA when Mark announced his change. And then you go like, what happened? I just convinced you how important it is to update faster. This is what they did, and no one cares. So what the hell? For realizing why it happens, we need to understand how we update software. And I have a diagram. So let's say an update is available, and then you need to decide, do you want it or not? Sometimes there is nothing interesting, like Java 9. Like you go like, no, I don't want it. It's not, there is nothing there for me. And then it's like simple no, it's easy. But sometimes there are features that you want. And then you need to evaluate, are there any high risks? There are obviously software that was without high risks. And then you're like, yeah, sure, I will update. Why not? I don't know, like Snake game on your phone. I mean, why not? Worst case, it will be broken. I will play something else instead. That's fine. But if there are high risks, the next question will be, do we trust our software? So, who had a Mac, let's say 5 years ago, 2014? You remember when it was like OS update available? You were like, yes, sure, why not? Everything will be fine. That's because you trusted the vendor. You trusted Apple. Today, any idiots except of me that upgraded to this latest disaster?
Not yet.
Smart. We're not trusting them anymore. And the question is why? Why? Why we don't trust the vendors of our software? Why we don't trust Oracle with Java? Why we don't trust Apple with macOS anymore? What happened? So one assumption is they forgot how to test software. So in 2014, Apple did a great job of testing software, and suddenly they forgot how to do it. That's a strange assumption because we're actually getting better in testing our software. The problem is not the testing techniques, but the complexity of the software. So in JFrog, we manage binary files, right? We have artifact repository, and we have distribution platform, and we're all about binaries. So we measure everything with binaries, including the complexity. So we had a very scarce amount of binaries back in 2000, and then kind of continuous integration popped up. And continuous integration was about, okay, let's build binaries every night. So we had more of them. And then continuous delivery. Every binary that we build might end up in production, so we need to keep them around. And then infrastructure as code. Now our servers are binaries as well. They're like Terraform packages or Ansible cookbooks or whatever. Ansible rules, Puppet rules, Chef cookbooks, and Ansible playbooks. Thank you. And then microservices. Oh, fun! Let's make the services small, and each and every one of them will be binary with complex connections to each other. And then, like, boom, Docker. Every line in the Docker file I change, I generate new layer, more binaries. And then, like, serverless, okay, now every 10 lines of JavaScript code is a binary. Well, that's NPM actually, but also serverless. And then IoT, and then my light bulbs are running Docker container, like Kubernetes with Docker containers and what's not. Everything is full of binaries, complexity through the roof. This is why it's harder to test. Another thing, data. Now, when you think about like a lot of data, what unit of size do you think about? What's like a lot? Petabyte. Thank you. Petabytes is a lot. After petabytes, we have no. After petabytes, we have exabytes. Now, exabytes is a lot, and only then we have zettabytes. So zettabytes is a lot of data, like tons of data. Now, obviously, well, this is a biased report. It's from Seagate. They sell hard drives, but you know what? Half it, divided by 10. It's still so much data we cannot even imagine today, right? And that means that the majority of our organizations won't be able to reproduce our production environments in staging for a reasonable price. Just because it's too expensive and it doesn't make any sense. So instead, we're going to test in production, which is fun. Personal story, number one. If you search in Facebook, empty envelope from China, you'll find a wonderful story about my wife. She had an account on AliExpress. And she ordered there very seldomly, but suddenly, a couple of years ago, we started to receive empty envelopes from China, from different vendors on AliExpress, to our house. Sometimes they were empty, sometimes there were like weird artifacts in them, like a white sock, or a red tape, or a piece of black cloth, or a hairband, or a plastic ring, like really weird artifacts. And we were like, what the hell is going on? And a friend of mine, Leonid Igolnik, who is an SVP in Signal Effects, now part of Splunk, he came to visit us one day, and we were telling him this story, and he's like, well, yeah, why are you surprised? They're testing in production. They took a piece of the production database and testing their, their provisioning stuff. Are the orders coming through? Are they ship everything and what's not? So yeah, this is already happening. We realized that staging doesn't make any sense, and we started to test in production. But back to our story. This is why we don't trust our vendors, because testing becomes very, very hard. So next question is, can we verify the update? Sometimes it's just not worth it. For example, if it takes me half a year to verify that all my services and all my servers and everything works with a new version of Java, and the new release of Java it's every half a year, it doesn't make sense for me to adopt any new version of Java, because by the time I'll finish testing it, it will be a new one. And even if I'm like, okay, I want to do it, it will be very time-consuming and very expensive. So what this pressure creates, I won't even update or it will cost me a lot of money, is that the vendors have to put a lot of food on the table. This is very Russian reference, by the way. A lot of food on the table to make it worth it for us. We have a trade-off of features that we really want against acceptance test costs, right? And this is a bad place to be, because this is not the way to update faster. Because to put a lot of features on the table, we need time, and that makes the updates very scarce. Can we cheat around this formula? Well, partially. What we can do is, update is available, do we want it? Yes, it's fine, and no one asks you. You will get it anyway. And this is fine for low-risk applications. So, for example, your browser. Anyone knows which version of the browser they are running? It's just got outdated. Because you know what? Worst case scenario, I will have an open Safari once in a while. It's a low risk. Twitter in your browser, there is no even way you can know this, because it's kind of a service, it's updates when they want, no one asks you, and then they have this new UI, everybody hates it, or the UI is broken, but still no one asks you because it's a low risk. Worst case scenario, you will stop shitposting on Twitter, you'll go shitposting on Instagram or whatever. Low risk. Twitter on your smartphone? Anyone knows the version of any app on their smartphone? No. How about the operating system? Here you know. Your Android 9, your iOS, whatever version they are, you actually know this stuff because this is a high risk. So this idea of asking anyone works, but it only works for low-risk applications. And that's because some practices that need to be adopted are not adopted. And this is what this talk is about. So, again, personal story. 2.5 years ago, like 3 years ago, I bought this wonderful Google router that's called OnHub. It was produced by TP-Link, and what they promised is a self-improving system. It's called now Google Wi-Fi, highly recommended, great. It's a great Wi-Fi mesh that's vanished the concept of something wrong with the Wi-Fi from our lives, I hope forever. It's great. And what brought me in is the promise of self-improving system. That means that once in a while, they will send an update, and boom, new feature appears in the router. They didn't know how to do not porting mapping. One day they know. They didn't know how to do like screen time for limiting kids' devices access. One day they know. Super cool. I was very excited. 2.5 years ago, February 17, I was on a trip somewhere. My wife is calling me and she's like, I came from work and the kids are sitting in the dark. And I'm like, do we have a power outage? She's like, no, the internet is down. And they go like, Alexa, turn on the light, Alexa, turn on the light, and nothing happens. So this day they learned there is a physical switch on the wall, but also everything was fine with the internet when we called our internet provider. And then I get this email. I'm on a road, and this email basically goes like, oops, sorry, we screwed up. We sent you an update that reset your router to a factory reset. And now there is nothing we can do because it's not connected to the internet, so we cannot fix it. So you need to go and set it up from start. The thing is, you need internet to get an email. I was on the road, so that was fine, and I came back and I fixed everything. But this is an example of a failure which is tolerable when we are talking about consumer devices. But think about the edge computing devices that are attached to, I don't know, a solar panel in Sahara Desert, or a wind turbine somewhere in the mountains. This is problem because update can go catastrophically wrong, overhead patch cannot reach the device, and then you're stuck because to get there it takes like 3 days of helicopters flying and then 3 days on a camel. I don't know. It's like it's important, it's expensive, it's time consuming, there is no way. So what you can do, you can have a previous version saved on the device prior to update. And then you roll back in case a problem has occurred. A lot of manufacturers do that, right? So for example, Tesla does that. They actually have a previous version of their entire system on the still kept in the car after you install a new one, and they actually keep it around for a while because they do system check, but they also want to see how the car behaves when it's driving. And if there are some problems, they know how to roll it back. But some systems lack it. For example, the on-hub, and that's a problem. Now, this concept is not new. Think about it. You remember you had desktop that were connected to displays, like notebooks with the display built in. And then when you change the resolution, it has like, click here, because otherwise it will be reverted. And that was for catastrophical update that you did, and you actually don't know about it because you have no screen. So that's exactly the same concept, right? I'm going to mention another concept that we kind of forgot that exists with us for years. This is one of them. So this is obviously an IoT example. You know, it works for edge devices or routers, or it's not. But I would claim that the T in things relates for everything. Your notebooks, your phones, everything is, in the end of the day, IoT, and the principles of continuous updates apply to all of them. There are some principles that look natural for us in server computing world, like on servers and or even on notebooks, but for some reason we completely forget about them when we talk about IoT stuff, and the other way around. So let's talk about more IoT fun, updating cars while driving. Because as I mentioned, what can possibly go wrong? Jaguar I-Pace. Jaguar is a UK, it's like a British brand, right? So that will be like really painful for you because that's a great car. They sold like maybe 80 the entire year. Since it was released this year. A couple of months after the release, June 8th, there is a bug, software bug in brakes. I mean, that's okay, but for some reason, they had to create a physical recall to update software. Now, first of all, it costs tons of money. And second, you cannot force the update. Problem with brakes, it's kind of severe, but what can you do? You can send a mail, and you can send a mail in a red envelope, like, because it's like your fucking brakes, and that's all, right? Over-the-air software updates, cheaper, can be forced. You can just force the update, and are generally great. What's better than just over-the-air software updates are continuous software updates. Continuous software updates are like software updates but better. And for example of when the continuous software updates could really shine, I'll use another car that is packed with software, and that's Tesla. Tesla is a great car, has a couple of very annoying bugs. One of them is what's called phantom braking. And you can see there are tons of posts about how phantom braking is real. So the way it works is you drive on an autopilot, it's a sunny day, there are no cars nearby, it's a highway, like straight, there are even no clouds. There is nothing that autopilot can determine as an obstacle on the road, and still, in the middle of driving, it slams the brakes. Like really slams, like uncomfortably, to the lock of the seatbelts. When I drive alone, I'm like, okay, that's software, that's bugs, I'm a software engineer, I know how it works, I'll give them a slack. But when I'm with my family in the car, there is no way I can convince them it was the car and not me. So they're like, why did you do that? And I'm like, that wasn't me. And they're like, no, you didn't slam the brake, why? So this is really annoying. And there was